Hello, this is Margaret Ajibade, the STEM Positive Disruptor, with Mayor's conversation with An Duong.
Hello, Margaret. Yes.
He works in this with Rolls-Royce. He works at Rolls-Royce, sorry, and he's a founder of More Than 3D. So he's going to talk more about it. I do love. So thank you so much for coming on board. The reason why we have this podcast, we want to educate, we want to raise awareness, we want to change perception and demystify what STEM is all about. That is science, technology, engineering, mathematics, and also maybe to bring the public into our domain, because sometimes the public don't fully understand what we do, and that also that there's so many diverse roles. And 3D printing is an example of that, and how we're using it. I mean, it's moving away from the traditional way of doing things to using a different technology to actually produce the same product as well. And but also it's also to show the other roles that we have in the industry, so that when parents and young people are thinking about their journey or subject or what profession, they have that information available. They can see what we do, and this gives them something to at least help them to make that informed decision at the end of the day. So without further ado, I welcome Anne onto this podcast, and I do want you to just feel free, just talk about what you do, and then we'll lead on to the enjoyable part of it. I'm sure everything's enjoyable, but also there's 3D printing as well. So welcome, Anne.
Yeah, thank you very much for the kind of introduction, Margaret. So, well, I guess I think your first question is a bit of an introduction of myself, isn't it? So, I think I can just tell you briefly about who I am and what I do, and but basically that. So, my name is An Duong. I actually come from Vietnam. I came to UK about just more than 10 years ago. So I studied in the UK. I graduated from Nottingham University back in 2015 with a master's degree in manufacturing engineering and management. And then I joined Rolls-Royce as a graduate back in 2015, January 2015. And I've been working for Rolls-Royce ever since. So yeah, I mean, I am an engineer, an aerospace engineer, you can say. I work in this industry for quite some time now, and I really enjoy it. I really enjoy what I do. And as part of my job, I get to do a lot of exciting stuff, around technology, around engineering, obviously. And a few years ago, when I moved to one of the facilities that Rolls-Royce used to have in Hucknall, which is not too far from Nottingham, I had a chance to get involved in 3D printing. So funny story, because I learned about 3D printing a lot when I was at university, but it was all theory, and I didn't really get to know actually how it works, how you actually 3D print something, only until when I started working in that role when I moved into Hucknall. I got involved in 3D printing because we were designing and basically making tool to have us making parts for the jet engines. So I got involved in 3D printing more and more and more. And outside of work, I am actually really passionate about STEM. So I've been doing a lot of activities around the STEM space. I go to school and talk to children. I've been attending and supporting various STEM events for Rolls-Royce and also outside Rolls-Royce as well. And it's just something that I really enjoy doing over the years. So when I got into 3D printing, back the day, I just thought, hey, I really like STEM, right? And it seems like I really like 3D printing as well. So why don't I just try to combine the two together? Maybe I can do something to, talk to the students, talk to the children with an innovative approach by using 3D printing. So that's when I started to design and make models, STEM models. And I use those models to tell them how things work. For example, I used to design quite a few jet engine model, the simple version of the jet engine.
but it's detailed enough for you to be able to explain to the young children how a jet engine works. And you know, I just keep doing, you know, just keep doing designing more and more and more in 3D printing, and you know, making more models. And what the good thing about 3D printing is, you know, it helps you turn your idea into reality. And it's always better to have a physical object that you can take with you to any schools or you know, university, and show it to the audience. Because one of the things I learned from, you know, when talking to kids is they're a lot more engaged if you give them a physical model, right?
Yes.
Something that they can feel, something that they can touch.
Yes.
And you can explain, you know, a lot of things using that model. You can explain about, for example, how a jet engine works, and you can explain to them, you know, how you actually make that model using 3D printing. And then you can start, you know, talking to them about the technology, how does 3D printing works, you know, how do they, let's say, if you have an idea, how do they design it, you know, how do they turn it into a reality, you know. So yeah, it's to me, it's one of the vehicles that I've been using to convey the children to study more about 3D printing in specific, but you know, also in general, you know, in science and engineering in general. And I think, you know, so far, yeah, so good. Yeah,
Do you know,
looks like, you know, yeah.
yeah, I do love it, because even though you work in industry, you work with Rolls-Royce. One of the things about your passion, which is you said 3D printing, is that I love your mission statement, or you know, you said what we want to do is create joy, passion, and purpose using 3D printing, and that shows that we as engineers have fun as well. We can have, and this is your fun part. This is what, as you said, you create jet engines, you take to schools and you show, because when they see something that's physical, they can relate to it, they can see how things work. And this is, to me, so important, because when we talk about young people, they, even though they're not sure about something, when you go to show them what you do, because they can relate to you, and you show your enthusiasm about it, it makes a huge difference. What I would love you to do, please, is to expand more on the technology behind 3D printing, please, because even though we talk about 3D printing, not everyone knows, indeed, not just very briefly, what it means, because it's used in so many different industries as well. You know, it's used. Yeah, go on, Karen.
Yeah, so the funny thing of 3D printing, you know, when people talk about 3D printing, it's still a very new technology to a lot of people. But it's not actually that new. You know, 3D printing has been around for quite some time. I think probably more than 20 years, if I remember. So, you know, the very first people tried to print something, you know, in 3D.
So, you know, the technology has been around quite some time, but I think only until, you know, maybe the last 6-7 years, and 3D printing started to become a lot more accessible to many people. And I think, you know, that's when people like myself, for example, started to get into 3D printing, because, you know, back in the day, you know, only if you had like millions and millions, or, you know, or basically a lot of money, right, to allow you to purchase, you know, these very expensive machines, which basically now you can still purchase them. But, you know, back in the day, it wasn't very accessible, right? You need to have a lot of money, or you have to work in, like, for example, a research center, right? Where you have some machines there, and you can get access to the technology, and you can start doing research, you can start doing study on them. So it was a very accessible back in the day, and that's why, you know, when I studied about 3D printing when I was at university, all I learned was, you know, theory, right? You know, what technology we talked about, you know, how it works, but I never really see it in action.
Yeah.
But like I say, the technology has, you know, advanced, you know, really rapidly in the last decades, I would say. And thanks for, you know, many companies in the industry at the moment, you know, they have really tried to make the technology become a lot more accessible. So today, right, you know, even if you want, you don't know anything about 3D printing, and if you really want to learn from it, you don't need to spend a lot of money, to get a 3D printer. The 3D printer become, cheaper and cheaper and cheaper.
Yes.
And even if you want now, you can go on Amazon and eBay and just get yourself a 3D printer for like maybe 100 quid, and you can start learning from it, learning how the machine works, how the technology works. And it's fun as well. The technology is really fun. Imagine you have a design, you have a CAD model, and just print it like you print the paper, but you're printing a shape in 3D.
Indeed, it's a mold, isn't it? And it brings it to life, isn't it?
Yeah. So basically, 3D printing, or the correct word is additive layer manufacturing, is a technology, right? And it basically, there are loads of different technologies that you can use for making parts using additive layer manufacturing. So basically, the main difference between additive layer manufacturing and subtractive manufacturing, which is the traditional manufacturing method, is if you use subtractive manufacturing, for example, if you're going to use CNC machines or lathe or drilling machine, whatever, you always start with a billet of material or block. So you always start with something which is bigger than your finished product, and you start to remove or subtract material from that billet of material or steel block, whatever, and once you've done all of that, it gives you the finished parts.
Yeah, indeed.
Now the problem with that is you can be spending a lot of cost, just removing material, in order to achieve the final part. Now, additive layer manufacturing is the opposite. So you started to build your finished part, layer by layer, and because of that, the material that you have to remove is very close to zero. Of course, depending on the complexity of the chip that you want to print, sometimes you still need to use support material, and you still need to remove the support afterwards. But compared to subtractive manufacturing, it's it saves you a lot in terms of waste or the material that you have to remove afterwards. So basically, one of the most common technology and affordable technology in additive layer manufacturing is 3D printing or FDM or FFF. So FDM stands for field deposition modeling. So you can imagine, you have a spool of filament, right? So like plastic filament, and you feed these filament through a very hot nozzle, right? And at this very hot nozzle, the filament will be melted, right? So when the filament is melted, you basically, you program where you want the nozzle to move on a build plate, and it will move into those locations, right? And because the material that you fed through the nozzle is melted continuously, so you start to deposit, a layer, a very thin layer of your product. And once you've done with one layer, your build plate will move down to allow the nozzle to start printing the next layer, and it will continue to do that until your final product is fully built. So that's why when people talk about 3D printing, it's about building up your model layer by layer, until you finish your product.
Get the end result. Yeah. Thank you for the explanation, because I think it's so important that sometimes we talk about 3D printing, but people don't know the process behind the scene and what it does and how it's brought to life. And thank you so much for explaining that in very layman's language that anyone can understand. So thank you so much for that, because 3D printing is used in so many different industries. It's used in in construction, it's used in the dental industry, in the hospital. It's used so many different places. So the opportunities are there for you for it to be a skill set that you can acquire. But going back to, because it's quite interesting because we, as I said, we want to enthuse our young people, we want to get the public to understand what we do and the different roles that are available in the industry itself. You work for the aerospace industry and you've been doing that since you graduated. By the way, I did a master's in manufacturing engineering and management as well. So hey, I do like the so it's quite nice. I never thought about it, but yeah, it's quite good to see someone else doing the same thing as I did. But I know you love what you do, and I can hear the passion in you. What would you say, very briefly, because I do want to make sure that everyone hears you, is what would you say is the good, the bad, and the ugly of working within the industry itself? So since you've been working in the industry, I know you're a STEM ambassador, so we know use 3D printing to, I guess, engage our young people. But as your role, your current role, or your role since you've been working since 2015, what would you say is the good, the bad, and the ugly? Very briefly.
Yes. So, working in the aerospace industry, right? I also the thing, you always work at the forefront of technology. Right? So you always have access to the latest technology, on the market at the moment. Clearly, because the market is so competitive. So if you stop innovating, right, you're going to lose. That's why the very good thing, if you're really, really passionate about engineering, working in the aerospace industry will give you the opportunity to always work at the forefront of technology. And I think that is brilliant. Now, the bad thing about working in the aerospace industry, I wouldn't say is a bad thing, but the aerospace industry is a very, very highly regulated, industry. Obviously, you can imagine, if we might, jet engines, or exactly, or aircraft. You can imagine, like, if you are sending people on an aircraft and flying them from one place to another, you don't want anything to be, to happen to the aircraft or the engine, when the air. So safety is one of the things that we really, really need to focus on, most when you're working in this industry. And that means you have a lot of process to follow, because every time, if you don't follow the process, something wrong can happen. And if something wrong can happen, particularly in flying, then, the consequence of that can be really, really bad. And that means, yes, you have to do everything, to the letter of the law, basically. There's a lot of process you need to follow. And even if you don't like it, then, well, there's nothing you can do with that, because all the processes are in place to ensure that every product that we make are safe. And
it has to be,
exactly, yes. So yeah, sometimes it's it's frustrating, because in order to do one simple thing, you need to follow a very lengthy process. But at the end of that, you can always ensure that, okay, whatever I do here will ensure that the product will be safe, and the people that using our product or service will be safe as well. So yeah, I mean, that is that I would say is one of the disadvantages. I wouldn't say it's a bad thing, but clearly, let's say if you work for a startup, for example, then the pace that you go through to get things done can be a lot quicker, right? You're probably talking about days, hours. It's not like that, when you work in an aerospace industry. But yeah, it is just something that you have to learn. And you have to follow. The ugly thing, ugly thing about working in the aerospace industry, that is very tricky.
You don't have to.
Anything at the moment, to be honest with you.
You don't worry about it. It's not. It's just basically because every industry is different. I think what we want to showcase is what, if there are issues, the things that we would like to see change. And we're not saying there's issues, or we're not trying to say it's a bad place, because you're, for example, you're very passionate about what you do anyway. That's heard in your voice and just to what you do, and that there's protocols you have to follow through. Talk about the process. Safety is a big thing, because you're dealing with engines, and it has to be the fine details. You can't just put out anything, because if you do, you know, well, they always consequences to that. So, but which is understandable. But you know, also you're saying it's a fun place that, you know, it's innovate. There's so much innovation going on within the industry itself. So, you know, so I do love your enthusiasm. There's so much we can talk about, but you know, we're looking at young people and how we can bring them into the industry. We're also looking at their parents or the public as a whole, and we want to be able to give them that information. So when they like looking at options for their children, or helping their children to make those decisions to get into, maybe through their education and then go on to the profession. So what would you say is very key and to be able to address that? So if there are things that you've seen that could improve, because as a STEM ambassador, I know that the thing is that there are children who are aware that there's an opportunity, that maybe the schools invite you, or maybe you go to an event and you're there on behalf of Rolls-Royce, but still not everyone has that opportunity. And I think we need to be always aware that not everyone is going to be in the right place at the right time to get those sort of information. So what would you say? Give me 5 things that you think would be critical or would help them. So help our young people come in. But when you think about young people, think about their parents, their guardians, those who are helping them, the career, the education system. I mean, you know, I know that you studied in Vietnam, then you came over to do your master's. So I know that this education system may be slightly different, actually maybe a lot different. So yeah. So what are the things that you think could really help our young people and the parents? Because we want to bring the public into our domain.
Yeah, sure. I mean, I want to give, you know, some of the advice to the children or the parents out there, you know, about how to be prepared, you know, how to let's say if they want to get into a STEM career, then I would say, well, have a look at, you know, what jobs going to become important, you know, in this industry in the future, because clearly you can see that, you know, the technology is advancing every day, right? You know, a lot of jobs that we do today didn't even exist, you know, in 5-10 years ago, and things like 3D printing, like I said, you know, it wasn't even accessible to a lot of people back in the day. But as you can see, as the technology keep advancing, the technology is now a lot more accessible, and going forward, you know, the technology is going to be revolutionizing how we design parts, how we make parts. So clearly we will need people with you know, knowledge and experience and know how to, let's say, how to make parts using 3D printing, for example, rather than just, you know, using the traditional method at the moment. So you can imagine, like, you know, that means, for example, you know, if you are still a young children in school, or if you just join a company as an apprentice, you know, instead of just train your children or train your students to use all these traditional machine, like, you know, the drilling machine, the lathe machine, CNC.
Yeah.
Now, I think it's time for them to think about, oh, you know what, 3D printing or additive layer manufacturing has become a big thing now, right? And there's going to be a huge demand for people who has that level of knowledge and skill to operate, you know, machines, 3D printing, you know, machine in the future. So in that case, you know, why don't we just give them more options, or, you know, start training our children or our students to learn about the technology and to learn about how to operate these machines, or even better, you know, to learn how to design things that can be manufactured by additive layer manufacturing or 3D printing, rather than, you know, design things and with a mindset that, wow, you know, that can only be made by, you know, subtractive manufacturing methods, for example. So I think, you know, going forward, clearly there are roles, right, that will start to come to the market which do not exist in the past.
in the past. And I think that very much depend on how quickly the technology will advance. And I think 3D printing is just one very good example that I want to use here. But apart from 3D printing, there's many other things that I think the students and the parents can look into and try to predict what skill set or what knowledge all these big companies out there in the future will require from the labor.
So
yeah.
can I interrupt? But then again, the public will not know where to go for that. So do you think the industry needs to tell them what type of skill set they need? Because technology is evolving so quickly. As I said, 3D printing is just one of so many options available there. So would you say that the industry needs to spread the word? These are the things we're looking for in the next 5 to 10 years, or even 2 to 10 years. Because if we don't know what we're looking for, it's difficult for you to train up somebody to achieve those goals, isn't it?
That's right. And I think it's quite a good point, to be honest with you. And I think it should come from both, not just from the industry. So from the companies working, let's say, in the aerospace industry or in automotive industry or engineering industry, in general, need to go and make themselves really clear. Okay, this is going to be the the technology that we want to invest in the future. Hence, we're going to need people who have this level, expertise in this area. Let's say, for example, 3D printing, right? But also, I think, from the education system, for example, like in school, right? When you talk about primary school, secondary school, A levels, they also need to think about, okay, what they can do today to better equip their children or their students for the future, and that can be 3D printing, right? And I think a lot of schools now are having are buying a 3D printer and let the children play with that and teach them how to operate them, how to design things from these printers. And I think that is just the best way to go forward, really.
Yeah. Hands-on.
You get you get the student actually involved in using the technology and exploring the technology themselves, rather than just showing them all the videos or photos or lectures.
Yeah, so important. Yeah,
exactly.
It has to be hands-on. It has to be practical, because people learn by visual and hands-on, because they can see the transformation from nothing to something. You're quite right. Yes. So what other ones do you think? So there's two. So what's it? I mean, you don't have to. You don't have to.
Right?
Yeah. But if you don't have it, that's fine.
Yeah. Well, I think look, there's so many things that you can talk to the student or talk to their parents about the STEM career, but I think, to me, I think nowadays technology are becoming a lot more accessible to a lot of people, and you can clearly see that we are going through the industry 4.0 at the moment. So there are even more jobs will be created in the future that requires people with completely new, different skill set or different way of thinking, compared to the old school people in the past.
Like us.
Yes, exactly. So to me, right, I mean, I think that means the teachers, right, or the school plays a really important role in defining what is going to be the strategy going forward to ensure that the employability skill of their children or your students will be looked at and will be aligned to ensure that they will learn all these necessary skills and knowledge to to be able to fulfill, you know, those workforce, you know, the future workforce, basically. Because otherwise, you know, if you just keep teaching them the same thing, this, you know, year after year after year, then I think, you know, in the next 5 or 10 years, all these skills will become outdated, and they will need to go and learn, you know, the new skills again anyway. So why don't we just start to think about, okay, in the next 5 years, right, things like 3D printing, additive layer manufacturing will become, you know, even more popular in this. You know, big companies will start to, or you know, start to utilize this technology a lot more than today, to push their design limit, push their manufacturing limit to the next level. So why don't we start today, you know, by teaching our children, our students about the technology, and just get them involved, you know?
Yeah, indeed. Well, you know something, you're right. Again, you know, it's the teachers, it's the school having the technology in place. It's the teachers being aware and how they can embrace this and again to learn and really, it's also having the right teacher skills, isn't it? It's having those who understand the technology or know about STEM, because you have to have the expertise to be able to, and also be able to communicate it, isn't it, as well? But also industry has a big part to play, because one of the things the industry is saying is that we've got the skill short. Yes, we know that, but unless you tell us what it is in advance, you can't train a kid or get them ready for that time when they then you know, graduate. They're ready to fill in those roles, because we're saying that there's that skill shortage, and some areas that need the expertise. But as you're saying, technology is evolving all the time, but they're indicators that tell us what type of technology is out there and what has been tried, has been tested initially, but now they feel can be rolled out to a wider audience. Do you know, and I can talk to you all day. I can, you know, I really enjoy our conversation, but you know, also what I do want is for the audience, which is the public, to hear what you said. I love your passion. I love the fact you're creative in your own industry. It's what you enjoy, and you can see that in your speech, in what you say. I do love that, you know, and I'm so grateful that you also you're a STEM ambassador, goes to school, and you know, enthuse the young people with, you know, 3D printing, showing what's possible. So thank you so much. I really appreciate this. You know, taking time out to speak to us today. So thank you. So here is Margaret. Thank you. So here's Margaret Ajibode, the STEM positive disruptor, with Mia's conversation with An Duong. He works with Rolls-Royce, but also is the founder and director of More Than 3D Limited. And he's passionate, he's creative, and he wants you to have fun too. He's a fun guy. So enjoy this, because this STEM podcast is to raise awareness, educate, raise awareness, change people's perception, and demystify what STEM, science, technology, engineering, mathematics is all about. And I hope this would have enlightened you today about what 3D printing is all about today. So thank you very much. And again, once more. So yeah.
Yep. Thank you.